Assalamualaikum and good day everyone. My name is Nur Sarah binti Abdullasani. I'm from Group 2 Dynamic together with Muhammad Naim and Muhammad Aiman.
Hello and good day everyone. My name is Muhammad Aiman bin Samad and I'm from Melaka.
Hi everyone, my name is Muhammad Naim bin Jamal Abdul Nasser and I'm from Naim.
Hi everyone, welcome to Project 2. After choosing a location for bicycle center which is L50, there is a space suitable for a fast food center. In Project 2, we will produce homemade fast food and design a suitable layout that can minimize the cost of movement. As you can see on the content, we choose pizza, kacang and sandwich as our homemade fast food. We provide certain analysis for this product. So let's go. After our proposal on UTM Bicycle Center has been successfully approved, extra space near Bicycle Service Center could be utilized for a fast food center. Fast food center should be able to serve food or either on-site purchasing or delivery across all the college. Arrangement of the facilities department use several analytical methods and steps to reduce the cost of movement in fulfilling demand. Basically, our problem is the service center has extra space which could be utilized for a fast food center, and addition of fast food center is possibly an opportunity in increasing the total profit earned. Fast food center can be a hangout place while the customer are servicing their bicycle and for delivery to college service. A complex analysis required to determine the size and location for each department in reducing the movement cost in between department. For Project 2, we have three main objectives, which is to design an appropriate layout that can ensure the smooth flow of work, to minimize production at lower cost, and the third one is to minimize worker, raw material and equipment movement. And how are we doing data collection for this project? Same as Project 1, KNL table is done by collect what we know, what we need to know, and what are the learning issues. On this project, we need to know the working hours, the sizing of the premise, the number of workers, and the costing, include utilities and raw material. So, let's go to our first product. Anyone who says that money cannot buy happiness has really never spent their money on pizza. There are three main ingredients for pizza, which is dough, topping and sauce, and two choices of protein, which is ground beef and shredded chicken. And also there are two different kind of people who like pineapple on pizza and normal people. Bill of material or BOM is important because we can see which one is we need to buy and which one we gonna make it. Inspired from Arabs, kacang is well known in JB, and that is why UTMians should try this meal. And this is the structure chart of kacang. Look complicated to make, but definitely worth it. The bread we use is Bengali bread, which is known for its softness, and much type of bean is used, and the main is for medamas. The great taste is come from the sauce. Side meal and topping are option, but it's a must. To make kacang, roughly 43 ingredients we need. As you can see, the option for make is slightly more than pizza. You want heavy meal but light in weight? Introduce you the dynamic sandwich. And this is the structure chart of sandwich. As you can see, the process of making the dough is almost the same as pizza and kacang. And for sandwich, we have topping, shredded chicken and vegetable. Referring to the BOM of sandwich, from 25 ingredient, 15 ingredient we decide to buy and 10 ingredients we make.
Okay, we will proceed with the layout planning. We construct overall product layout, which has been shown in the chart, where we combine the three structure chart of this product: pizza, kacang, and sandwich. And we will also state the quantity that is needed for each of the component involved. The process of the product is displayed in the table, where we combine all the process involved in this component of each product. And as we can see, there is a few process that is similar from each of the product, such as the process of making the bread and the dough for the pizza. These are few machines that we use, such as mixer, griddle, blender, where blender is used to blend the ingredient of the sauce. We also use oven for the pizza and the bread, and then there's also kneading machine for the making of dough and the bread. We construct from the chart table by multiplying the quantity required for each of the component, which is in gram, multiply with the number of demand, where we assume the number of demand for each of the product is the same, which is 50 packs. Continue with the form to chart analysis, where we find the number of relationship of this department, which is the 12 department, and we obtain that the relationship it has 66 relationship. And from this number of relationship, we multiply it by each of the percentage for the letter of the closeness rating A, E, I, O, U. And as we can see from the table, the A is displayed in the blue box, while the E is displayed in the green box, and I is displayed in peach box, while O and U, we can see it is in the white box, which is blank. After we finish the from to chart analysis, we proceed with the relationship chart, where this chart is all about we display the closeness rating, the 5 letter A, E, I, O, U, onto the triangle looking shape, where we can see that it shows the priority of every department to be placed close next to each other. For example, as we can see, assemble is very important, has a high priority to be placed next to make, since the closeness rating value is A. Next, we continue with the block plan analysis. The new from the chart table is constructed based on the block plan method, where firstly we find the maximum load flow from the previous prompt to chart table, which is the value is 33,700 gram, and then we divided this value with 5, which the 5 represent the number for the letter of the closeness rating A, E, I, O, U, and we get it as 7,500. And then we get the range for each of these letter, where for the range A is 33,000 until 37,500 gram, and then for the E 22,500 to 33,000 gram, and then for the range for the I is 15,000 until 22,500, while for the E is 7,500 until 15,000, and for the U started from 0 until 7,000 to 500. The difference between the from to chart based on the block plan method and the previous one is, as we can see, the classification of the A, E, I, O, U letter is different from before, where we can see there is a presence of letter O in this table, while from the from to chart table previously it doesn't have the letter of the O. A new relationship chart is constructed based on the from to chart table of the block plan that we have showed before. And as we can see, there is only one letter of A, which is the department of the assemble and mix. It has the high priority to be placed next to each other. Next, we draw the block diagram layout based on the previous relationship chart that has been shown, where the line that we draw is based on the letter A, E, I, O, U, where the closeness rating for A is represented by 4 lines, and then the letter A is represented by 3 lines, while letter I is represented by 2 lines, and lastly the letter O is represented by 1 line. Next, we proceed with the layout selection, where we drew 3 different type of layout, but we assume the distance for each of the department is 1 meter, and the cost per distance is 50 cents, where we can see the calculation is as shown above. This one is a sample of the layout 1. For the layout 2, the arrangement of the department is shown in this slide, where we can see there is a few changes of the arrangement of the department in the diagram, and then at the bottom is the value of the cost of movement for layout 2. Lastly is the layout 3, where it is shown in this slide, where the value of the cost of the movement for layout 3 is quite higher compared to others. And for the discussion of this project, you can say that the product structure and bill of material that we built, it depict the detail of the product such as ingredient, quantity required, and the flow process. And several components from this product use the same type of machine and undergo similar process. Well, from the overall product layout that has been illustrated in the chart for the layout planning analysis, it assists in identifying the quantity required for each of the component involved in the making of each product. And then constructing the from to chart table, it will show the closeness rating between the department, and the relationship chart is drawn based on the from to chart table. And then the block plan analysis is done for the layout selection, where a new from to chart table and relationship chart were constructed. And then the block diagram layout is used to identify the appropriate arrangement of the department based on the calculation that we have done. And the layout 1 is chosen due to the low cost of arrangement compared to the layout 2 and layout 3. For the conclusion, it can be concluded that the analysis of the selected product utilizing the bill of material known as BOM, structure chart, and flow process, it helps in understanding the details of the items. And then the relationship chart, it assists in identifying the placement of department that must be prioritized in the layout development based on the closeness rating that has been calculated. One of the effective methods to reduce the financial waste is by reducing the cost of movement between the departments.
Now let's move on to project 3, which is additional feature to current existing facility. Primarily, our facility consists of bicycle service center. Then we see a new opportunity for us to create more money, which is addition of fast food service. This addition of new facility had caused such number of customers in a single time. So we need to add several facilities to deal with new emerging demands. So we decided to add 4 new facilities, which is the first one parking lot, second one material handling, the third one restroom, and the last one food services. So prior to the selection of additional facilities, there are several layout planning algorithms and standards are utilized as our main engineering approach. Next is problem statement. We need to rearrange the current existing parking lot because it is not relevant anymore. This is the result of the type of car used by the student, which is not compatible with the current existing parking lot, which designed mainly for standard car. Regarding food service and material handling, the customer segment is not consist solely on deliver, it's also covering on a customer who prefer dine-in meals. There are 2 main objectives for this project. The first objective is to restructure the current existing parking lot in order to cope with the increased number of customers. The second objective for this project is addition of entrance and food service feature to be able to fulfill demand for customers which prefer either dine-in or delivery. Next is on facility parking lot. In this slide, we can see an image of satellite capture plan view of the facility location. In this image, there is 2 boxes, which is box A is for the location of the facility and box B is the current existing parking lot which need to be rearranged to increase its capacity. The objective of rearrange of the current existing parking lot is to increase the current parking lot capacity, which is 45 parking lot. Second one is to provide handicap parking lot, which is 5% of the total parking lot. The third one is to provide at least 75% for compact car parking lot. Next is criteria and assumption made for us to rearrange the parking lot. The first one is we need to reserve a total number of 8 parking lot for our 7 employees using the ratio of 1.25 employees per parking lot. The second one is handicap parking. We design handicap parking based on Facility Planning 4th Edition dan Perkeliling Ketua Setiausaha Kementerian Kesejahteraan Bandar, Perumahan dan Kerajaan Tempatan, which stress that handicap parking should be placed near the entrance or door and use 90-degree parking. It requires minimum width of 3.9 meter, which is equivalent 12 feet 10 inch, inclusive of transfer area, and we need to provide based on the 5% of the spaces. The third one is the parking is designed for compact and standard size car. The fourth one is we design based on the maximum number of 20 customer, which equivalent to 20 car in a time. The fifth one is the available parking lot is measured at 150 feet in the wide and 148 feet deep. Last one is one-way traffic. In this slide, we can see the technique that our group used to measure the width of the facility current existing parking lot. Next is step of parking lot arrangement in terms of depth. We decided to choose W1 and W4 module for both compact car and standard car. We plan to design the parking lot consists of 3 row module column. The first module column is W1 for standard car, the second one for W4 compact car, and the third one W1 compact car. So next is we test for the feasibility of this combination, and we find that this combination is feasible because it is less than the limitation of 148 feet. Next is step of parking lot arrangement in terms of weight. In this slide, we are determining the total number of cars per module. Using the total number of cars per module row, we are able to determine the total possible parking lot for the new arrangement. And from that, we need to provide a total number of 3 handicap parking based on the needs of 0.5% from the total parking space. So the next is the calculation for the handicap parking. The finalized parking space rearrangement will have a total number of 17 parking lots, which is 48.9% increment from the previous parking lot. The parking space will consist of 3 module rows. The first module row is the closest with the premise. This row consists of 13 parking spaces of module W1 for standard cars, and together with addition of 3 handicap parking lots. The placement of handicap parking lot in this row is essential as per local government rules. The selection of standard car for this row is based on consideration for family customer with kids, which made about 18% of the total parking lots. The second and third row is module W4 for compact car, and the last row is W1 for compact cars. Summation of these 3 rows will have a total number of 54 compact cars parking lot, which is approximately 77% from the total parking lot. We intentionally designed the parking space to have a high number of compact cars based on the needs of at least 75% of compact car. We decided to construct 2 restrooms based on gender, and this distribution of the gender are as follows. We determine the total number of space needed by each restroom based on first water closet, second one lavatories, third one entrance, and the last one is for the 40% of allowance.
Prior fulfillment of dine-in requests, the premise should be equipped with a facility of food service. This facility should cover either the selection of table, space requirement of cafeterias and vending machine. Food service facilities should be planned by considering the number of employees who eat in the facilities during peak activity time. So our planning are 2 shift lunch break and tea time, which includes 9 workers and 61 customers, and we are using square table 36 inches times 36 inches. Our cafeteria is classified as commercial, so 36-inch square tables use average space commercial from table should be utilized, which is 7 square feet per person, and we include a vending machine as alternative use for service requirement. From the calculation, we required total area of 1,260 feet square, but if vending machine area is to be operated beside the stall, 100 feet square space should be set aside for vending machine. As a result, the vending machine will require 170 feet of space. L50 is centrally located and positioned. Therefore, the distance from the farthest workstation is minimized. This location is also within 1,000 feet of all permanent employees' workstation, and we are allowed delivery of food. Next, we move on to material handling. Material handling means providing the right amount of the right material in the right condition, at the right place, in the right position, in the right sequence, and for the right cost by the right methods. Material handling principles are important in practice. It is often the case that no mathematical model can provide extensive solution to the overall material handling problem. These principles provide concise statements of the fundamental of material handling practice. There are 10 material handling principles recognized by the College Industry Council on Material Handling Education, which are: firstly, planning principles; second, standardization work principle; and then ergonomic principle; and the fifth one is unit load principle; and the sixth one is space utilization; number 7, system principle; and then automation principle, environmental principle, and the last one is life cycle cost principle. There are 4 material handling equipment, which is transport, positioning, unit load, and storage. A material handling planning chart can be used to gather information pertaining to a specific material handling problem and to provide a preliminary examination of the alternative solution. So here are our planning, which is number 1 is raw material store on a container, and we are using big crates. And secondly, raw material store in box, and we are using box. The third one is raw material transferred from the supplier to our storage, and we are using a 1-ton lorry. And next one is raw material transport from vehicle to storage. We are using manual hydraulic scissor lift trolley. We are also use sack trolley to move boxes from vehicle to storage, and then we inspect the raw material before stock using crates. Then the raw material is stored in double door freezer. Then we are using single metal rack to store the raw material, and we have a step ladder in case we are moving the boxes to the high place. Next one is we are using kitchen chef to store raw material in the kitchen, and the last one is we are using various Tupperware to store ingredient.
In conclusion, from this project 3, we learn on how to determine the personal requirement for customer and employee, because facility means serving the people. These include parking lot, restroom, material handling, and food service. This is intended to meet the basic requirement of employees and customers. The design of parking lot should take into account the space requirement of various types of cars such as compact car, standard car, and not to be forgot about the handicapped parking spaces. Material handling also play an important role in the smooth operation of the facility, especially for fast food service center which deal with storing and serving raw material. This ensures employees to concentrate more on providing excellent customer service.